Hi, this is Sung and I'm the Principal and Director of Sky Academy. In the last episode what we did was looked at basically how to differentiate trig functions. And so we've worked out that in essence the differential of sine or the derivative of sine is cosine, the derivative of cosine is minus sine, the derivative of tan is secant squared. Okay, so basically we learnt to differentiate sine, cos and tan, and then we also looked at how we might apply the chain rule to certain types of questions. Okay, this episode I want to just get stuck into doing some examples just so that you get familiar with how to differentiate trig functions. Now, when it comes to this table over here, it just reminds me, I know that I've used the chain rule, etc. for just the sine functions, right? But of course, you would just do the same thing as I've done here with cosine and tan if you were to have cosine and tan as well. Okay, so just don't feel like this applies to sine and to sine only. It also applies to cosine and tangent as well. Okay, so let's have a look at some examples over here, and I'll step to the side. I'll be referring to the tables as we go. The differential of sine 4x would be, and you would use this one here, right? Differential of sine is cosine 4x. But the differential of the inside of 4x would be 4, which you need to multiply out the front. Okay, you multiply it out the front because that's what the chain rule asks you to do. Okay, the chain rule or the function of a function rule gets you to multiply the differential of the outside function, which is the sine x, by the inside function, which is the differential of 4x, which is 4. So you need to times that. Same thing here, the differential of the outside function cosine would be minus sine, and then the angle is x on 2. The differential of the inside, which is x on 2, would be just, the differential of x on 2 is a half. So you need to multiply that out the front. Got that? Let's have a look at this one here, because I just want to highlight the difference between the derivative of tan x squared, so x squared is your angle, as opposed to squaring the tan of x. This is the square of the tan of x. This is tan of the square of x. Okay, they're different and they will yield different results. So let's work this one out. So the differential or the derivative of tan x squared would be, what's the derivative of the outside function, which is sec squared, times by the derivative of the inside function, which is 2x. So it's 2x sec squared x squared. That would be the answer to the derivative of tan x squared. Alright? This one here, on the other hand, will work like this. Alright? The power of the tan will come out the front. So 2 lots of tan. Take 1 off the power, which is 1x, times the differential of the inside function, which is tan x, which ends up being sec squared x. So the answer for this one will be 2 tan x sec squared. Got it? The differential of this one, or the derivative of this one, 3 sine x squared plus 4x plus 7. We use this rule here. So basically, the 3 remains out the front. Alright? You multiply by the derivative of that, which is 2x plus 4 is the derivative of that, times the derivative of sine, which is cosine of that whole function. Alright, and to simplify, 6x plus 12 outside of cosine x squared plus 4x plus 7. Let's have a look at this example. This is a classic example where you might use the product rule. Okay, the product rule. Okay, so let's use the product rule there. So the derivative of the first times the second plus the derivative of the second plus times the first. Okay, so it's 2x sine x plus x squared cosine x. And that's your answer for that particular example, because u equals to x squared, u dash equals to 2x, v equals to sine x, v dash equals to cosine x. And basically what you've got, the differential of uv is equal to u dash v plus uv dash. Okay? Let's have a look at this example. The derivative of sec x would basically be the derivative of 1 on cosine x. Do you see that? So it's 1 on cosine x, and 1 on cosine x would be cosine x to the power of minus 1, which ends up being minus 1 cosine x to the power of minus 2 times the differential of cosine x, which is minus sine x. Minus minus becomes a plus, so it becomes sine x over cosine squared x, which becomes sine x over cosine x times 1 on cosine x, which is equal to tan x sec x. Got that? Alright, let's have a look at this one. This is a classic example of where you would use the quotient rule. So you basically let u equal to 1 minus cosine x, v equals to 2x, v dash equals to 2, v squared equals to 4x squared, u dash equals to Freudian slip. Differential of cos is minus sine. With the minus out the front will just be sine x. Right? So that'll be equal to v squared u dash v minus uv dash, which is equal to sine x times 2x minus 1 minus cosine x times 2 all on 4x squared equals to 2x sine x plus 2 cosine x minus 1 all on minus 2 all on 4x squared. The 2's can cancel. Factorise the 2's out and cancel. So it's x sine x plus cosine x minus 1 all on 2x squared. Okay? Good. Alright, so that is basically a couple of worked examples on how you might use differentiation or apply differentiation to various trigonometric functions. Okay, so if you need to go back and refer to it, go back and refer to it. What you need to be good at is both the chain rule or the function of the function rule, the product rule, and the quotient rule. Thank you very much for watching.